Assalamu alaikum everyone. I hope you all are fine. I welcome you all to Learn Online. Before we start, I would request all of you to please like, share and do subscribe my channel, and do not forget to click on the bell icon. The topic that today we'll be discussing is calibration and the four basic kinds of thermometer. So calibration is that basically the range that how much a thermometer can measure. The maximum and the minimum point of a thermometer. So whenever we are going to calibrate, or we are going to give a number that how much a thermometer is going to measure in what measure. For example, if you have a scale, in that scale we have calibrated it in a normal scale. We have calibrated it from 0 to 30 centimeters, and we have marked each meter in certain centimeters. Now this is your calibration, and this is the same, in the same way we are calibrating a thermometer as well. So first of all, what we need to know is that what is the upper point and the lower point of a thermometer. So the upper point is usually 100 degrees Celsius, that is boiling point of water, and the lower point is your the freezing point of water, that is 0 degrees centigrade. Now moving on, we will be discussing the four basic kinds of thermometers. So the first one that we will be discussing is mercury in glass thermometer, or the clinical thermometer. That is a very good example of that. Now this mercury in glass thermometer is used to measure high temperatures, and just because of the reason that the temperature at which it is boiling, the boiling point of mercury is 357 degrees Celsius. It is having a capability or a capacity to measure a temperature range of 357 degrees centigrade of any body, and the freezing point at which the mercury is freezing is minus 39 degrees Celsius. So if anybody is having a temperature of freezing point of, for example, minus 20 degrees Celsius, so mercury has the capacity or the capability to measure it. But in usually cases, clinical thermometer is used to measure in between 0 to 100 degrees centigrade. Now our second example is alcohol in glass thermometer, and this alcohol in glass thermometer is basically used for low temperature bodies, and those bodies which are having a boiling point of 78 degrees Celsius or below 78 degrees Celsius. For example, if a body is having 78 degrees Celsius temperature, or 77, 76, 75, it is that alcohol is having the ability or the capacity to measure its body temperature, and its freezing point of the alcohol is minus 114 degrees centigrade. So it is having the capacity or the ability to measure the temperature of a body that is having a temperature of minus 114 degrees Celsius, or minus 113, 112, and so on below that. Then comes the liquid crystal thermometer. It is a heat sensitive liquid crystal that is changing color to indicate the temperature change. Whenever a temperature change is coming, what will happen, that it will change its color, and we are able to measure that how much our temperature has changed. The fourth one is your constant volume gas thermometer. Now it name clearly suggests that the volume of the gas is remaining constant, and we are going to change the pressure. As everyone knows that volume and your pressure are inversely proportional to each other. So if you are changing your pressure, you have to keep your volume constant, and if you are changing your volume, you have to keep your pressure constant. So in this case, we are keeping our volume constant, and we are changing the pressure. Now what will happen, that when the temperature is rising, the pressure is also increasing, as pressure and temperature are directly proportional to each other, and pressure and volume are inversely proportional to each other. So if temperature is changing, the pressure is increasing, and if you are increasing the pressure, it will indicate that there is some temperature change. I have just mentioned this proportionality of pressure and volume just to tell you that if you are changing your pressure, you have to keep your volume constant, and if you are changing your volume, you have to keep your pressure constant. One thing is always constant, and in some cases we are changing pressure and volume, and we are keeping the temperature constant. So in these kinds of thermometer, what we are doing is that we are keeping our volume constant and we are changing our pressure. So a slight change of temperature will indicate your pressure change, and we will be able to measure that. We will be discussing two main points. Number one is that what is your linear thermometer, and number two, what is your non-linear thermometer. Now a thermometer is called linear if the liquid is expanding by the same amount by every degree rise in your temperature, and the graph to show this is your straight line graph. Now what happens is that whenever a temperature is given to any liquid, that liquid will start to expand, and this expansion is going to be shown in the range of your thermometer. Now if this range is in accordance or is in calibration with that basically your range of thermometer. Okay, now class, the two main points that we are going to discuss is your linear thermometer and your non-linear thermometer. So linear thermometer is basically a thermometer in which the liquid is expanding by the same amount by every degree rise in temperature. That clearly means that if your body is increasing its temperature, the liquid in the thermometer will also increase the length of its liquid accordingly, and the graph that is showing it is this graph. This is a straight line graph, that if the temperature is increasing, at the same time what will happen, that it will also increase the liquid will also increase its height in the thermometer. And the same the opposite of this is the non-linear thermometer. What is happening here is that it is not increasing regularly with the rise in temperature. If you are increasing the temperature, it is not increasing the length. Sometimes it is increasing, sometimes it is decreasing. So this is an ordered graph. This is not showing a straight line graph. Now the second point that we will be discussing is the range of a thermometer. Range of a thermometer is basically the maximum and the minimum point it can measure easily. So the 2 points that that depends on that how we can increase the range of any thermometer are: number one, if you are increasing the diameter of capillary. Capillary is basically the tube of the thermometer. So if you are increasing its diameter, its range will automatically increase as more liquid will come into it, and more temperature change will be shown. So with a good temperature change, a small distance will be traveled, and with this the range of the thermometer will be increased. The second point is if you are decreasing the volume of the bulb. If you are increasing the bulb is basically the lower hand side that is basically sensitive to a temperature change. So if you are changing a temperature, the bulb is going to measure it. So if you are decreasing the volume inside that bulb, what will happen, that less amount of liquid will travel, and due to this the range will automatically increase. Now here are some set of formulas that are used when we are measuring temperature of an unknown liquid or an unknown substance. So if you are using a mercury in glass thermometer and you want to know the temperature of any object that is placed in any kind of liquid or in any kind of object, so what you will do is that the formula that is basically used is theta. This is your theta, that is equal to L theta minus L naught or L0 divided by L100 minus L0 multiplied by 100%. So this is basically the temperature. Theta is your temperature, the unknown temperature, yeah, that you really don't know that what is it. You are going to find it, that what is it. So this L theta is basically the length that is to be traveled by that liquid by the rise in temperature or the decrease in temperature, and this is L0 is the length of the mercury that has traveled at 0 degrees Celsius, and this L100 is basically your length when it is at 100 degrees Celsius. So we will be calculating all these values and we will be putting in this formula. We will be multiplying it with by 100%, and we will be getting the temperature that is of the unknown liquid. Then is your resistance thermometer. I have explained it to you before that a resistance thermometer is working on the principle that whenever current is flowing in a body or there is some temperature change due to the flow of current, we are going to measure it. So that measurement is basically calculated as that theta is equal to r theta minus r naught divided by r100 minus r theta multiplied by 100%. This r theta is the unknown resistance, and you will be getting its value whenever that body is the current is flowing in that body. This R0 is the resistance of the body at 0 degrees centigrade. This R100 is the resistance of that body at 100 degrees Celsius. And you are going to put all these values, you will be multiplying it by 100%, and you will be getting your desired value, that is again theta, the unknown value that you want to know. And then is your Celsius thermometer, that is your basic clinical thermometer. This is theta over 100 is equal to x theta minus x0 divided by x100 minus x0. This x theta is the thermometric property, or that property that is going to change with temperature. So if you are increasing your temperature, this will also change and you will be able to calculate it. And this x0 is that thermometric property of any object at 0 degrees Celsius, and this x100 is the thermometric property of that object at 100 degrees Celsius. We can simply write it as that theta, the unknown value or the desired value, is equal to x theta minus x0 divided by x100 minus x0 multiply by, we are taking this 100 to this side, multiply by 100%, and you will be getting your desired value. So this was all class about temperature. I hope you all have had a very good understanding of this. Please do like, share and comment, and do not forget to subscribe. Thank you so much.